Hello everyone. Good morning students. I welcome you all to the second problem discussion in the maximum subarray using divide and conquer. Let us quickly get started. So today we are going to discuss the question 2 which has come in the winter 2024-25 at VIT Vellore. So the question is like this as projected on the screen. So what you will achieve from this video, the complete solution for the question 2, how the exam evaluator expect for the full marks, how to write this question in the exam, how the question paper setter modify this problem in the exam. Okay. So this is the question. Define a maximum subarray problem. Find the series of contiguous elements that result in maximum subarray for the given array. Minus the array element are -2, -3, 1, 4, -1, 3, 5, -4, 6. Write the recurrence relation and time and space complexity of the algorithm. So the question paper setter expect or the evaluator expect this, the problem definition and the broad distribution of the marks will be like this. Problem distribution, you will get 1 marks. Maximum subarray algorithm pseudocode, you will get 4 marks. Recursion call graph on the above problem instance, you will get 4 marks. And the recurrence relation and the time complexity, you will get 1 mark. So the final solution look like this. So I will highly recommend you to solve the problem on your own and match this with the final solution. If your final solution matches, you can directly go to the next problem. Otherwise, you can see the detailed explanation, which is in the next slide. So we'll call the recursion call graph. There are 10 elements indexed from 0 to 9. So first call will be the maximum subarray, that is abbreviated as MS A0 to 9. Next, it will have the this call graph. The MS A09 will break the this is the original problem. This will break into the two recursive problem S1 and S2. So MS maximum subarray A0 to 4, maximum subarray A59. 4 we got by adding 0 plus 9, 9 by 2. So low equal to 0, high equal to 9, and low plus high by 2, 0 plus 9 by 2, that is 4. And so the first call will be MS A04. Next call will be MS A59. MS stands for maximum subarray. Okay. And there would be third problem, maximum crossing subarray, that will span from 0 to 9. So these are the three function call out of this. So the complete recurrence call graph, the function call graph will look like this. MSA09 will call MSA04, MCSA09, MSA59, and so on. So and all the leaf node are the base case, like MSA00, MSA11, MSA22, MSA33, MSA44, MSA55, MSA66, MSA77, MSA88, MSA99. So these have this one element. So these all are the base case. Okay, and it contains only one element. Base case contain one element only. So what will be the output of this recurrence call graph or the function call graph? So this will come here, right? From here will come here, from he will come here, here down to the MSA00. So it will return -2 single element, and the low index is 0, high index is 0. So it returns -2 A00. MCS will we are going to see MSA11. So it will return -3, low equal to 1, high equal to 1. Then MCS. So what will be the maximum crossing array when we take this from 0 to 1? So the mid is 0, mid plus 1 is -3. We have to compulsorily take the mid element as well as mid plus 1 element and expand in the left and right direction as much as possible, maximizing the sum. So here it will be the -5. MCS will return -5, 0 and 1. We are including both the element. So maximum of all these three will be the -2, 0, 0. So this will be the return by the MSA01. Next, going in the same manner, MS22 will return the 1 and the low index is 1, high index is 1. MCS A02 will return, it has to include the mid element -3 and mid plus 1 element. It can exclude the other element if the sum reduces. So the net sum here by considering -3 and 1 is -2, and maximum of these three will be equal to the 1. So that will be passed here. Okay. Similarly, we calculate the MSA33. MSA33 is nothing but 4. Low is index is 3. High index is 3. MSA44 is -1. Low index is 4. High index is 4. MCS34. So again, we have to consider the MCS34. So there are two elements. Mid is equal to 4. This mid is equal to 3. So we have to consider this. Mid plus 1 equal to -1. So we have to consider both elements. Net sum equal to 3, and low index and high index has 3 and 4. So maximum of these three at this point will be returned by MSA34, which is the 433. Okay, and then at this point the maximum of all these three will be 1 5 minus 4 is 5, and the low and high index is 2 3. So this is the call graph or the output of the recursive call graph on the left hand side. Now let us calculate similarly for MCS 809 and on the right hand side. Okay, so are you excited? Let's move ahead. So MCS A09, it means that we have to find the maximum sub array in this range, complete range. Low is 0, high is 9. So let us calculate the mid. Mid is 0 plus 9 by 2, that is 4. So it must include this element. Okay, the element 1. Okay, and it has to extend in the left hand side as much as possible. So we can extend 4 increasing sum, we can extend 1 increasing sum. We cannot include -3 because it decreases sum. Again, you cannot include -2, so it decreases sum. So this side we got this sub array that maximizes the sum 1 4 -1. Okay, similarly it has to include the 3 mid plus 1, and we have to take as much as possible in the right side. Okay, so 3, of course we'll take 5, it is increasing the sum. We cannot ignore the we cannot take the -4 for now because it is decreasing the sum. But when we see the 6 minus 4, there is net increase of 2, so we'll consider up to here. Again there is a 1, so it is also increasing the sum by 1. So in the right hand side also we'll take up to here 3 5 minus 4 6 1. So the net sum here we get the 4 plus 1 5, 5 plus 3 8, 8 plus 5 5 13, 13 plus 1 14, 14 plus 6 20. These are the positive term, and there are two negative, -4 and -1. So -5, so 20 minus 5, that is 15, and the range low is 2 and high is 9. So this is how the MCS A09 is calculated. I hope MCS A09 is clear to you all. If not, write your doubts in the comment and I will get back to you. So moving forward, similarly, the MSA55 will return the 5, the net sum, and low index is 5 and high index is 5. MSA66 will return 5. Okay, so MSA55 will return 3, not the 5. So there is a slight mistake here. It will return 5, not 3. Sorry, it will return 3, not the 5. So 5 5, and this will return 8, and this will return 5. Okay, so maximum of this is 8, and similarly we'll proceed and we'll get this. So at this level you see that MSA59 returns 11 and 5 9, and the maximum of these three is a 15 2 9. So when you what is the input to the array? This is the input to the maximum sub array. The 10 elements consisting of -2, -3, 1, 4, -1, 3, 5, -4, 6, 1, and it returns the maximum sub array return the maximum sum possible, that is 15, and the low index 2 and high index 9, and these are the sub array that consist of the maximum sum, and this is the final recursive call. There is a slight mistake here. Instead of 5, you have to have here 5 5 has to be 3. Okay, so just a small corrections here. Okay, so problem definition, how to define the problem. Given an array of integers, find a non-empty contiguous subarray ai to j, the max or the maximum subarray whose values have largest sum. Maximum ij k from I equal to j, maximum ak. This is how you formally define the problem. What are the constant or the edge cases? The range of I and j ranging from 0 to n-1. N-1 is the size of the array. J is greater than equal to I. These are the constant. Another constant is the contiguity constant. The element must be next to each other. We cannot skip any in between element. And there may be the challenging cases that some number may be the negative that decreases the sum. So this is how you will write the problem definition for 1 mark. Next, you will write the algorithm. This you will get 4 marks. So maximum subarray, the function for maximum subarray, We have already discussed in detail in the last two videos. So please go through that if you are not clear with this pseudocode. Then the maximum crossing sub array. Okay. So this will consist of 4 marks, and then the recurrence relation, and you have to annotate each of the term. The base case is the maximum sub array for the right and left sub half, 2tn/2, and theta n for the calculating the maximum crossing sub array, and theta 1 to combining or comparing all these three. So the net recurrence relation will look like this: Tn equal to 2tn/2 plus theta n, which can be solved using the second case of the master theorem, resulting in time complexity as n log n and space complexity in log n due to the recursive call stack. The maximum height of the recursion call graph will be log n. That's why the space complexity is log n. Okay, so how to proceed, how to write in the exam in the optimal time? If the algorithm is asked, quickly write the algorithm, because it will not take much time to write the algorithm and there is a less chance of error. Write the time complexity derivation, properties of divide and conquer if they ask, or the recursion call graph. Like in this question, they have asked the algorithm, they have asked the time complexity derivation, they have asked the problem definition. So these three things I will write quickly. So this will give me 4 marks. This will give me 1 mark. This will give me 1 mark. So as a result, I have secured 6 marks within less than 5 minutes, 3 to 5 minutes, and without any trouble. Then the cream answer is the recursion call graph, which will consist of 4 marks. So then after that, I will try to draw the recursion call graph with precaution. That should cost me another 5 to 3 minutes. So a net 10 to 12 minutes, I will finish this answer. Okay, so this is the problem that we have solved just now. And this is the step marking, the problem definition 1 mark, maximum sub array algorithm pseudocode 4 marks, the recursion call graph 4 marks, and the recurrence relation and time and space complexity 1 marks. Okay, so what are the variations that a question paper can ask? They may change the numerical problem. So if you are clear how to solve, you can solve this on any numerical problem. They will ask the algorithm plus time complexity, easy marks to score, 4 to 5 marks. They may ask the properties of algorithm, divide and conquer, algorithm design pattern, and why divide and conquer is applicable in this case. This is very less chance, the correctness proof of the algorithm, but this is, they may ask for 2 marks or like that. Okay, to draw the rough sketch of the correctness proof. Okay, so what is the summary? So we have solved the problem using divide and conquer. There were the 4 steps in this particular question: problem definition that consists of 1 mark, the recurrence call graph that consists of 4 marks, and the algorithm pseudocode that consists of the 4 marks, the recurrence relation plus time complexity, time and space complexity that consists of 1 mark. So maximum sum, we got the 5. The sub array was this, resulting in the index from 2 to 9. The time complexity was n log n, space complexity of log n. So as a no as a pro student, I will try to write the algorithm, problem definition plus recurrence uh, plus recurrence relation and time and space complexity first, and then I will draw the recursion tree to secure the full marks. Okay, so this is the properties of divide and conquer. The recursively divide the big problem into the smaller sub problem until the smaller problem is small enough to be solved directly. Okay, so you divide the large problem into sub problem, recursively do like that, and conquer the smaller sub problem recursively. After that, you combine the sub problem solution to produce the solution of original problem. Okay, so this is the fundamental algorithm design technique. Why divide? What is the benefit of the divide and conquer? It has the faster asymptotic runtime, uses recursion naturally. Naturally, we divide a task into subtasks. We keep on dividing until the task is small enough that we can finish in unit amount of time. Sub problems can be parallelized, so we can have the parallel algorithm that can solve the individual sub problem, reduce the complexity versus the brute force. It achieves the significant performance gain over the brute force. It is efficient for large data set. So a classical example of the divide and conquer are merge sort, quick sort, binary search, stress and matrix multiplication, closest pair of point that comes under the geometric applications. Time and space complexity, general recurrence relation is Tn equal to Atn by B plus Fn, where A is the number of sub-problem and N by B is the size of each sub-problem. Fn is the cost plus divide plus combining the solution of sub-problem to get the solution of original problem. This was the summary slide about the divide and conquer. Okay, so next class we'll quickly learn about the Karasuva fast integer multiplication, which is a very interesting algorithm where with one trick, you have reduced the time complexity from n squared to n to the power log 2 base 3, or log 3 base 2. And so this is the previous year question. We'll solve these questions step by step so that we can secure 10 marks. So in your exam, there would be either question on the Karasova fast integer multiplication or the maximum subarray, and you can secure easily 10 marks. Thank you, everyone. If you have any questions or query or any doubt, please feel free to write in your comments. And if you like the video, if you like the content, please share, subscribe, and like the channels. See you in the next video. Thank you, everyone.